Okay, so gonna talk through some mediation stuff today. Okay. Again, gonna talk about conceptual framework for mediation, and then we're gonna go through this classic causal models approach. These were old papers when I was in graduate school. They're now starting to get very old, but they are kind of like the foundation for us, so like understanding some conceptual arguments for establishing some of these mediated pathways. We're gonna go through, gonna talk about limitations of causal models. Again, this is just giving to give you some background on how to think about sort of what we might want to talk about in terms of directional paths, things along those lines. And then we're going to shift over to analysis of indirect effects, okay, and then some extensions for moderation, mediation, things along those lines, okay. So we've gone through and talked about regression. That's what you're working on right now, okay. And in those regression models, what we're doing is we're looking at, if I have these 4 or 5 predictors in a model, what's the unique association between X and Y, right? After I control for these other variables, which is good, right? There's a lot of interesting things you could go through and do, particularly if an area is new. But after a while, if we've gone through and demonstrated this again and again and again and again, this starts to become kind of boring, right? And saying, yes, in the presence of these other things, this holds a unique relation with my outcome, but I don't know, like it starts to become limited in what that actually says about the nature of that association, right? We're dealing with complex constructs, and just because something sort of outperforms in a predictive fashion above and beyond anything else doesn't really tell us anything about like how that relation plays out. Okay, so given strong evidence for an effect in the population, okay. So let's say, Katie, you're talking about honor and aggression, right? Sort of these different things. Once we've gone through and found that yes, these things are related over and over and over again, one thing we might want to do to expand the literature is we might want to ask, what are the factors that account for or maybe even cause these two things to be linked? Is it just that this thing directly drives this other thing, or is there some intervening variable that accounts for this association? Okay. And if we're doing this, we're talking about mediation. Okay. Anytime you hear mediation, you should start thinking about causation facilitation. Now we rarely can demonstrate that. And there are some people who get really, really, really wound up if you start to suggest that you've demonstrated causation in anything at all. But essentially that's what we're doing. We're saying X drives M, and M then drives the outcome. That's why these things are related to one another. Okay. So again, talking about mediation is a process where some external variable causes or facilitates an association between X and Y. Okay. So your mediator then is going to be for any variable that accounts for that base relation. Okay. So again, in your respective fields, we know that X and Y are related. Everybody knows that X and Y are related. Where we start to expand this and say, why are they related? What are the processes? What are the mechanisms that are creating this association? Okay. Here is how we tend to model this graphically, right? We're saying here's X, here's Y, here's my mediating variable. And once I account for that mediation, X and Y are no longer related to one another, because what we've done in this sort of very specific example is saying that this is the reason that X and Y are related. This is different than our moderation, right? Where we're saying that the relation between X and Y is sort of impacted, changed, either in strength or direction by some variable. People have seen this before, kind of this idea, this path here. And again, mediation, anytime you hear someone say mediation, they're talking about a causal relation, even if they're not saying causal, like that's what's implied stuff. Okay. So, for example, we should say the relation of attitudes and behavior is mediated through behavioral intention. This is some Sean McCrae stuff, right? Like the reason we see sort of my attitudes are related with the behaviors that I express are because of I intend to behave in some. I've chosen to sort of take this action, which is then creating that link. Okay. For anybody sort of, this is trauma focused stuff. Anybody familiar with EMDR as an intervention? Yeah, sure. What's EMDR?
I think it's like you follow a light that like bounces back and forth while you recount the trauma.
Yep. So this is in our area. It's an empirically supported treatment for PTSD. It involves sort of while you're narrating, sort of providing narration of your trauma, you're following a light back and forth, right? And there's an elaborate neuropsychological model for why sort of that eye movements or retraining stuff. It's exposure, right? Like you're doing exposure therapy while you're following the light back and forth. And so we could have an argument that positive effects of this intervention on reductions in symptoms is mediated by uh, non-directive exposure versus the eye stuff, right? So we're saying this is the reason this works, right? And we can test this. Is it the eye tracking or is it the actual exposure piece of things, right? So people seeing how we're setting this model up conceptually. Okay. And this is nice because this is how we often think about things in terms of some of these path models, right? Anytime you're running a path model, sort of here we're doing it in regression, sort of more elaborate models, we would probably in this day and age be running these as an SEM, but we're talking about different mediated or indirect paths here. So if we go back to the Stone Age of mediation, we're going back to some classic papers by Judd and Kenny, okay? And what we're doing here is Judd and Kenny is establishing what we now call the causal steps approach. Okay. And in order to demonstrate sort of this causal steps model, what Judd and Kenny is saying is that there's three things that need to happen. Okay. One, we need to have a relation between X and Y. Because if there's no relation between X and Y, there's no mechanism to account for because the two things aren't related to one another. Right. So in our original conceptualization, we're saying that we need to have a significant relation between X and Y before we can even start to talk about mediation. Right. Does that make some sense, folks? Yeah. I mean, like there's probably not reason to start talking about the mechanisms between the relation between eye color and the heat of the sun because those two things aren't related to one another. There's no reason to talk about anything. Okay. So number one, X and Y are related. And then two, where Judd and Kenny are saying is that each variable in the causal chain impacts the one that follows when all prior variables are controlled. Okay. What this is saying is that X is related to our mediator. Okay. And there's nothing prior in that chain to control for. And then my mediator is associated with Y controlling for X, right? Because X is happening earlier. And so we need to see sort of the evidence for this A path and this B path. And then our final condition here is that X demonstrates no relation for Y once we control for that intervening variable. Once we control for that mediator, that relation between X and Y that we have established and that we know so well, that goes away because we've accounted for the mechanism. Okay. If I'm looking at the relation between sort of this switch and the brightness in the room, right? That's pretty much a perfect association between those things, right? Well, once I account for electricity, right, or the breaker switch or something along those lines, now all of a sudden, so the position of the switch has nothing to do with whether the lights are on or off, if that's thrown, right? That's the mediator. That's the reason that sort of flipping the switch creates the change in the brightness or darkness of the room. We've accounted for the mediator. These two things are no longer related. People seeing the logic of the causal steps, this original causal steps approach. Questions about this? Pretty straightforward, right? Well, seems pretty straightforward, but as we start to go through and work with this model, some questions arise. And so we go through with Barron and Kenny in 86, have an adjustment to this, okay? Barron and Kenny say what we need to see, maybe in sort of tweaking this model, is that X demonstrates a relation with Y. Okay, we need to have evidence for this C path. Once again, because if there's no C path, there's nothing to mediate. So mediation would be nonsensical if these two things aren't related. Okay. And then we're saying X demonstrates a relation with my mediator. mediator demonstrates a relation with y here. And then what we're saying is when paths A and B are controlled for, what we're seeing is C prime, this dotted line here, is reduced with strongest evidence for mediation being when C prime is now equal to 0. Okay. So what we did with Barron and Kenny in 86 was loosen up this last component. Original Barron and Kenny are saying in order for mediation to occur, what we need to see is this path to go away, right? But what we find as we're going through is maybe there are reasons why X still holds some relation with Y, even if we count for that mediator. Okay, why might that happen? What do you think, Jayla? Why might we continue to see a relation between X and Y, even once we account for sort of this one thing that we think is a big driver of that relation?
I just think probably because there's other factors.
Yeah, that's a big one, right? There's probably nothing that we can point to in psychological science that anybody here is interested in that is singularly determined by one thing, right? Probably there's going to be other reasons why, and maybe X does have a direct effect on Y. Maybe the total effect is a combination of both direct and indirect effects. So even after we account for this sort of intervening variable, we're still seeing some connection. So we could still see C prime being some non-zero value. But what Barron and Kenny are saying, we need to see a reduction in that, right? That drops to some degree. People seeing the arguments, the conceptual arguments for the switch from Judd and Kenny to the classic Barron and Kenny 86 paper here. All right. So again,
Is it the same Kenny in both?
Yeah.
What happened to Judd? Did they have a falling
I
out?
don't know, like Judd, they like, get out of here, Judd. Like, hold me back. Judd was responsible for 3, and they're like, you're done, right? Like Judd pushed hard for this, not just in 81A, but in 81B, and then they're like, you can't. You're weighing us down, right? Kenny found Barron, like, sorry, it's awkward. We're breaking up. I found somebody else. We'll go through and sort of have this, right? So assumptions of our causal models here that start to become, and this is part of the reason that this starts to become very, very, very difficult to establish with confidence in the type of data that we collect. One, we're assuming that X causes Y and not vice versa. Okay. So if I'm saying low self-esteem drives depressive symptoms, I need to be prepared to make an argument for why depression doesn't drive low self-esteem, right? And I don't know that I can make that argument, right? It starts to become a tricky thing, right? In my area, it starts to become easier because if I'm saying trauma exposure impacts PTSD symptoms, probably PTSD symptoms don't cause you to experience the thing, right? We started to get into so there's a thing because we've got an external event driving some outcome, right? Versus the vice versa. But a lot of times with our constructs, we need to start thinking very, very hard about like, why is it X to Y and not Y to X? Okay. We have to assume that the mediator precedes Y in time and that our mediator is a plausible agent of Y. Okay. If we're going to make these types of conceptual arguments, and this is why this gets really, really tricky conceptually, we need to have some argument to say that yes, this thing happens before Y happens, and that this thing is a plausible driver of Y, right? This can't just be a random variable, right? And this is what starts to get tricky with mediation because we know, based on our regression models that we've already talked about, here's my outcome, right? And what I've got is X1, right? And so I see that there's an association there. But then if I have X2 come in, I throw X2 in the equation. Jack, what's going to happen in my regression model, the strength of X1 in this diagram?
X1 and X2 are going to be like similar.
What's that now?
X1 and X2 are going to be similar.
they're gonna be similarly correlated. What just happened, so relative to just the bivariate case where I had X1 in there, it's gonna go way down, right? Now, does that mean that X2 is a necessarily a mediator of the relation between X1 and my outcome? No, it just may mean that they're overlapping, right? So what I have to do is I have to make the argument that X2, one happened before this happened, and that this is a plausible driver of this and is related to this in some functional way, right? Because otherwise you just like throwing variables into a model and claiming mediators and stuff like that. You can't do that, right? So conceptually, we need to make an argument that our mediator precedes Y and that the mediator is a plausible agent of that outcome. Do we see the logic behind this? And then finally, we have to assume that the relation of X and Y is the product of some unmeasured constructs or processes or things along those lines, right? It's not because of something that we didn't measure, right? Again, this is getting the basic model specification. Everything that we have that needs to be in the model is actually in the model and accounted for with this. Questions about the logic of this causal steps approach? Okay. So, what makes this Barron and Kenny paper unique in kind of the historical sort of trajectory of psychological science is Barron and Kenny are recognizing cases of partial mediation. Okay, it's possible that sort of yes, even if this is a mechanism that's driving some variability in my outcome, there may be other things that are going on there, and that's probably almost always the case, right? So this is sort of kind of a something that probably a conceptualization that maps better onto the types of things that we're interested in, as opposed to some of this more simplistic model. Again, Jayla, if I'm looking at like sort of German perceptions of guilt, that's probably a multifaceted thing. There's probably not one piece of evidence that's driving everything or one personological factor. It's probably a complex interplay of things, right? And so here, when we're talking about partial mediation, we're saying multiple things could play into this, right? And some examples of these are really, really, really critical things to start thinking about as you're thinking about your own areas of research and if you're doing these types of analyses. One, we could say that X has both a direct and an indirect effect through the mediator, right? We're saying that here's my IV, here's my outcome. We're saying that part of this relation is passed through this mediator. This mediator is accounting for some piece of it. But then there's also just a direct Y. X is directly causing Y in some way. If I'm looking at the bivariate association, whatever that correlation is, not all of that is a direct effect, but part of it is going through directly from X to Y, right? So we've got both direct and indirect effects through my mediator here. We can also have a situation between where the relation between X and Y mediated by several processes, but only a subset are included in our model, right? Here, what we're saying is I've measured one or two things, but there are a whole host of other things that are driving and accounting for this relation. Technically, I haven't included those in my model. This means I've got a specification violation and sort of I could have bias coefficients, right? We tend to be less concerned about this than sort of folks like in econ or other places along those lines. They get into some causal modeling stuff. Has anybody taken an econometrics course or an econ course? Okay. They do things a little bit differently, and they're very, very much sort of more math-based, but in their regression models, they are trying to establish causality. The idea is if I've accounted for all possible reasonable causes of this, and sort of this thing is still holding, then this thing is causal, right? We don't do that in psychological science, but it's a different approach that some other areas make. Here we would say that like if we've got, there's a couple other variables that we haven't measured that have gone through, you need to be careful and to be cautious about interpreting things. So we don't have a well-specified model, but that can be something that drives that C prime path maintained in our model. We'd also see a situation where the indirect effect of X on Y through my mediator, okay, and this is going to be language that I use quite a bit talking about the indirect effect of X on Y through my mediator. This indirect effect here is not the same for all members of the population. Okay. What I'm saying is that yes, the effect of X on Y does occur through sort of this mediating factor, but maybe it only accounts for, but maybe that path is only in play for women and not for men, right? Or maybe people who have had this experience but not this experience, or people who have had sort of this type of exposure to something but not, right? Maybe sort of that mediated path is true for white European Americans, but maybe not for other people, right? What we're seeing is what we would traditionally call a moderated mediation situation, or a conditional indirect effect, which is kind of more sort of modern terminology. Basically, there's something that's changing the strength of that indirect path, right? For white European Americans, it's strong, and for sort of some other group, it's not there at all, right? And so for those folks, we're still seeing the transfer of X and Y here in this relation, right? Because for, let's say, half of my sample, this doesn't apply, right? So again, what we have here is a model misspecification because we've got some grouping factor that we haven't accounted for. So we need to be careful about sort of interpreting our coefficients, right? If we think that could be going on, but it's a possible sort of reason for sort of additional transfer here. Okay, this one's a little bit tricky. Do people kind of see what's happening with this? We're seeing some fourth variable that's going through and changing the strength of that indirect effect. That would be a reason why we're still seeing C prime. Other thing that can happen is what I have measurement error in my mediator that attenuates its relation to both X and Y. Okay. Here it's not model misspecification, I just have error. I've got a messy measurement of my mediator, there's just error there. So this effect is weakened and that effect is weakened because I've got error in my measurement. And so as a consequence, this maybe is capturing the full association, but because these paths are attenuated because I've got measurement error in there, we're still seeing some direct effect right there that's hanging out in that residual C prime path. So these are all sort of technical conceptual things that can lead X and Y to continue to be associated even when we account for the mediator. But the reason I want to go through and talk about this is because it starts to help you think carefully about sort of what's going on, right? Let's say for comps, you're reading a paper and they're running a simple mediation. They found an indirect effect. They're like, yeah, here's my indirect effect. They want to talk all about the indirect effect, which is probably why they ran the study, which is not inappropriate. But there's still a residual C prime path going on there. X is still related to Y, even if we count for that thing. Authors might not pay a ton of attention to that because that might not be the purpose of the paper. But you maybe as a sort of savvy evaluator of research might want to be like, hey, I wonder what's going on with this. And start to come up with your own hypotheses for why we may still see a connection between X and Y in these data, even though sort of the investigator isn't, right? There are interesting things to be drawn into hypotheses to be drawn from these situations. How are people feeling about sort of this general sort of kind of framework? It makes some intuitive sense, right? And so like it's kind of easier to think about. But again, if you're writing these types of papers, particularly if you're using cross-sectional data, you just have to be very, very tight in making sure like this is, yes, you could model it different ways. This is why I've modeled it the way that I have. All right. So how do we go through and analyze this? How do we go through and determine evidence for my indirect effect? Okay. One thing we do to start is we will go through, we will regress X on Y to establish this effect to be mediated, right? Again, it's hard to go through. It's going to be more complicated to make arguments for why you're presenting a mediation analysis if X and Y aren't related to one another in the first place, right? So probably what we're with a classic mediation approach with the causal steps, what we're going to do is we're just going to regress Y on to X to give you your C path, We're just establishing a relation to be mediated. Number two, we're gonna regress our mediator onto our predictor to determine this A path, okay? This is all super simple, right? This is bivariate regression in the simplest cases. I mean, this is basically, you could also get these two, the step one and step two from correlation table, you know? This is related, that's related. We're not gonna do that because there's other stuff that we wanna go through and do this, but so again, we're just establishing this preliminary or this initial C path and then the A path. And then what we're gonna do is we're gonna regress Y onto X and the mediator to establish a unique effect between my mediator, my outcome, above and beyond sort of our influence of that original X variable. Okay. So what we don't want to do with this, and write this down because someone will do this. What we're not doing is we're just going to run the correlation between my mediator and my Y, right? And just say like, oh, I have evidence of this B path. B has to be sort of the partial effect of the mediator on your outcome controlling for X, right? Because your mediator needs to be sort of accounting for that this sort of A path is in here, okay? So again, shared association with X must be assessed in testing this one here, okay? So step one, Y onto X. Step two, mediator onto X. And step three, we've got Y onto my mediator and my original X. And we're looking for this coefficient on the mediator to establish that B coefficient. Questions on this? Yeah, William.
When like setting that up, do you do like a hierarchical regression or does it not really matter?
Not really, because your outcomes are different, right? You're sort of here for step one, Y is the outcome. For step two, your mediator is your outcome. So it doesn't really fit in the hierarchical model, right? You could sort of put, I mean, you could do step one and step three, but usually it's just a series of simple regressions. Good question though. Other questions about this process? All right. So last thing, once we've gone through and we've run these, what we wanted to do is determine whether or not my mediator completely mediates the relation of X and Y by testing this C prime path, okay? If we don't have evidence for a residual association or unique relation between X and Y, once I account for that mediator, C prime has like a large p-value associated with it. From the traditional causal steps analysis, we would say conclude full mediation in this situation, okay? But even if we do have a residual path of C prime here, so we've got that we're still seeing evidence of a unique relation of X and Y, even after we account for that mediator. From sort of our causal steps approach, we would say that is maybe indicative of a partial mediation situation. So let's say this happens, right? We go through and we run through these steps and find that, yeah, we did have sort of X was related to Y, but then and so we have evidence of X related to mediator and some mediator related to my outcome, right? But still we're seeing this C prime path, okay? What we need to do is we need to, within the context of a causal steps approach, the extent of my mediation is determined by the reduction of the effect of X on Y once I control for the mediator, okay? In step one, I'm going to get a measure, an estimate for C. And then in step three, I'm going to get an estimate of C prime. What I want to see is that I'm seeing some sort of reduction in that coefficient from C to C prime. Okay. And so with the causal steps approach, what this is literally doing is it's looking at your coefficient for X in step one, right? And then you're subtracting the coefficient you get in step three for X. So you're taking C minus C prime And that's the metric of your indirect effect. Because we're looking at a reduction. It used to be here. Once we account for my mediator, it's down here, right? And that reduction is telling me sort of the extent of my mediation. Okay. Now, if I'm thinking about this not in terms of a reduction in C to C prime, if I want to think about this more as evidence of an indirect effect, which is arguably a better way to think about things because it's just a more flexible way approach, right? This C minus C prime, literally, if I take my coefficient that I got in step 1 and subtract it for the coefficient for X, I get step 3. That difference is mathematically equivalent to the product that I would get from the multiplication of A and B. Okay, they're the same number. If I take path A and I take path B and I multiply that together, it's going to give me the exact same number as C prime, at least in these simple mediation models. Okay. Which then means that if I'm going through and thinking about within this system, my total effect of X on Y, okay, this is C, right, is going to be equal to the sum of all my direct and indirect pathways. So I can go through and set up mathematically C, which is my sort of just my bivariate relation between X and Y, is going to be equal to the product of my A times B path plus that residual C prime. Mathematically, those numbers will all square to 0. Okay. Because again, if I'm looking at this, right, here's this solid line, this is my C path, this is the total effect. Like this is all the relation, all the shared variability between X and Y. That total shared variability is going to be the combination of sort of this indirect path and whatever's residual there. If I add sort of this with this, I'm going to get back to here. Okay, it's a closed system. That's all there is to we're just sort of portioning out this variability. Okay. Questions about sort of conceptually what we're doing with this? I'm feeling comfortable. Okay. So what we need to do is we need to determine then if we're going to say, if our rules say that we need to see some significant reduction in that C path, C to C prime, that reduction has to be some significant or non-zero value. What we have to do is we have to derive a standard error for that mediated effect. Catherine, what's standard error?
Okay, so it's I know it's the standard deviation of the distribution of sample means.
Yes. Okay. Almost perfect. Except in this case, it's not the distribution of sample means, it's just the distribution of my coefficient, right? So if I were to go through and say I've got sample size 100 and I've tested this model, right? And I were to go through and I've got sample size 100 and I were to go and run through this model and calculate AB, right? And then I were to grab another sample of 100 and calculate AB and do that again and again and again and again for all possible samples with replication that could be drawn from the population. What I would get is I would get a sampling distribution of AB, right? And my standard error would then be the standard deviation of that sampling distribution that I would get. So same thing as with the distribution of sample means, it's the same concept. Instead of mean, we're just talking about the distribution of this AB coefficient. Okay. We can also think about this. If I were to go through and run this study again and again and again and again and again, how much would I expect that coefficient to jump around from study to study, right? If my standard error is really small, it suggests that my estimate is likely to be pretty precise. If it's really big, I don't know, Jayla got sort of this a coefficient or a sample of 25. Cindy, if you run the same study with a sample of 25, you get wildly different results because this is just going to jump all the way around, right? And the idea is that the mean of your sampling distribution, this is gonna be equal to your population parameter. Okay. We're remembering sort of this piece of things, okay? Really important, sort of wanna make sure you got a good handle on standard error. It's a critical factor. And sort of one of those things that sort of goes through when we violate our regression assumptions. What's generally the things that it's being impacted? Often the standard error, right? So this starts to become critical and important concept. Okay. So if we're going to go through and we're going to run a null hypothesis test of AB, what we need to do is we need to get a sense for standard error. Okay. Problem is, and we'll get to this in a moment, that the sampling distribution of AB is a little bit tricky. Okay. But the solution that we've had around since 82, something known as our Sobel formula, our Sobel standard error. Sobel provides an approximation for the standard error for AB. Okay. And what we do, we calculate Sobel as taking the standard error of AB as equal to my B coefficient squared multiplied by the squared standard error of A plus A coefficient squared times the square standard error of B plus the standard error, the square of standard error for A, standard error square of standard error for B, take the square root of all that, gives us an approximate estimate for the standard error or the standard deviation of the sampling distribution of AB here. Okay. And then once we've got our estimate, AB, and our standard error of AB, then we can just create a test statistic. And this is given as a Z statistic. We just take AB divided by the standard error of AB, and that gives us our Z coefficient or our Z statistic. And then we just interpret our Z statistic like we would any other Z stuff. Okay. Katie, what if I were at alpha 0.05, what's our Z we're looking at? 1.96, right? So if I go through and I calculate this and I've got a Z that's equal to or greater than 1.96, I can claim evidence for this effect at alpha 0.05. Also note that because here we go, equals it's the same thing because A, B, and C minus C prime are equivalent values. Questions about this process? Okay, so what we're doing is this is our test of whether or not, because probably if I throw any other variable into my model, right? Because when we're if we're thinking about this as the reduction of C minus C prime, right? Here's the bivariate overlap between X and Y. If I throw any other variable in there in psychological science, probably that coefficient is going to decrease some, right? The question is it decreasing by enough for us to conclude partial mediation? And that's where we've got our Sobel standard error coming into play. People following the logic of this and sort of what we're trying to achieve or sort of kind of look at from a classic sense. Okay. This is cool. I like this. McKinnon and Dwyer in that paper, they're talking about quantifying the magnitude of mediation as a percentage of the total effect. I really like this. Okay. Basically, this is like an effect size for your mediation. Okay. Really easy, simple. It's just AB, whatever your indirect effect is, divided by A times B plus C prime, your total effect. I mean, just like it's like an eta squared for your mediation, kind of, right? It's just saying of the total effect that's there, how much is your indirect effect accounting for? Okay, a really, really nice intuitive metric for sort of just kind of for descriptive purposes to say in these data of the total effect that we're seeing here between X and Y, how much of this is accounted for by this indirect path. Okay. Nice, mathematically intuitive, informative. We'll have you go through and calculate that in the set.
And then just to clarify, AB is the like you multiply the two correlation coefficients of path A and path B.
Not the correlation coefficients. It'll be your unstandardized effect here times your unstandardized effect here. Yeah. And so you want to make sure that you get that. This relation A path essentially represents your correlation, except your correlation is a standardized coefficient. The correlation would be equal to your standardized coefficient that we don't want. We're using unstandardized coefficients here. And then B, that's a partial coefficient, right? Not just the bivariate relation there, because you need to account for X there. That's a good question. It's something that trips people up. So, gonna work through a conceptual example, okay? What we're saying here is, do attitudes towards support utilization account for the association between PTSD and social support? Okay. In sort of trauma literature, there's a relation between PTSD and social support, right? So it's sort of demonstrated again and again and again. It's sort of one of the more robust associations in the field, right? Everybody knows that PTSD is related to social support, so that's not new, right? So the question starts to be like, what is accounting for this, right? And in this situation, we're kind of turning this on its head, right? We're saying, does the relation between PTSD and reduced social support, is it at least in part accounted by attitudes towards support utilization? Okay. Oftentimes we talk about like, oh, if you have low social support after a trauma, you're going to develop PTSD. Right. Here we're turning this around and saying like, maybe people who are experiencing sort of post-trauma distress are maybe sort of, for reasons that are often good, suspicious of utilizing social support. So maybe it's not that low support is driving PTSD. Maybe PTSD is driving low support. And maybe that is because people who have experienced trauma are maybe not completely on board with the utilization or the benefits of utilizing support systems, right? We can imagine why that could be, right? So what we have is we have a measure of support, right? This is an indicator of perceived support range 0 to 7, support utilization. And here, higher scores are indicating more negative perceptions of utility of resources. Give Katie a high five here. Like you haven't gone through that. I'm assuming you've not seen your problem set yet. What's that?
Not yet.
Okay. Turns out, sort of in that problem set that I've been sort of giving people forever and ever, there's a sort of a positive correlation between age and mental control. If you look at the problem set, it just looks like as you get older, your mental control gets better, which I don't know, maybe is a thing. Kitty actually pulled the paper, looked at the table, was like, this is actually reflective of a negative association, which I didn't catch. So bonus points for you for like making sure we understanding directionality and sort of how we're going through and interpreting things. So just wanted to make sure that yes, higher scores on this utilization measure are reflective of more negative perceptions of support, right? Like sort of it's not worth reaching out to people. Everybody needs to be out for themselves, sort of that type of thing. And then we've got sort of in here a measure of PTSD right here. Okay. So step one, what we need to do is we need to go through and determine or sort of find evidence for an effect between PTSD symptoms and support. So here we've got PTSD driving support utilization. Okay. So step one, we need to establish a CPAT. We need to make sure that in these data, PTSD is in fact related to support. Okay. Cindy, in this first model, do we have evidence for my CPAT here? Yeah, right. So here we go through, we see some very clear evidence for my CPAT. And so here's my unstandardized coefficient, here's my standardized coefficient. Our effect size is here. You notice that my zero order correlation is the same thing as my standardized coefficient here because it's bivariate relation, right? So do we have evidence for CPAT? Yep. So check that box. Okay. Then what we're going to do is we're going to regress my utilization variable onto PTSD symptoms. Cindy, do I have evidence for this?
Sorry.
Do I have evidence for my APAT here? Yep, sure do. And again, very clear evidence. And it's looking like as PTSD symptoms increase, people are less willing to utilize resources, sort of given how this is scaled. And again, my zero order correlation is the same as my standardized coefficient because it's just a bivariate case. Okay. And then what we have is our final step. And here what we're doing is we're regressing social support onto both PTSD and support utilization. Okay. And so here we've got my C prime path, right? Before it was just when we were just looking at PTSD and support in the bivariate case, this was my C path. Here I'm getting C prime. This is the relation, the unique effect of PTSD on support once I account for support utilization. And then I have my partial correlate, or my partial coefficient for support utilization. This is a unique effect of support utilization on my outcome controlling for those original PTSD symptoms. Yeah. Cindy, do I have evidence for a unique effect of support utilization on perceived support? My B path.
Yes.
Yeah, I have some evidence here, right? So my B path here, and William, this is getting back to not just the correlation, right? We got the partial effect here of my mediator on my outcome controlling for that original X variable, okay? And then Cindy, I'll pick on you one last time. What about, do I have evidence for residual or unique relation of PTSD after I account for support utilization? No, I don't have it, right? So this went from something that was very clearly sort of present, right, to something that has functionally gone away, at least in terms of my interpretive purposes, right? I'm saying once I account for the indirect effect of PTSD on support through utilization here, there's nothing, at least in my data set, that I can say is sort of left over outside of just sort of random stuff hanging out here. People see how we're stepping through these models and sort of the conceptualization behind this. Yeah, Jayla.
Just a bit confused why you're calling it a partial mediation.
Oh, no. I'm not calling it as the partial effect. Right. So anytime we've got multiple regression, we're talking about partial effects, right? In that sort of this is the association of X and Y controlling for everything else. So not partial mediation here. Yes, by the causal steps approach, we would claim full mediation here because C prime, we don't have evidence that that's different than a zero coefficient. So we're saying this would be a case where the old school may have concluded full mediation. Great question. All right. Analytically, this is really easy, right? You're just kind of going 1, 2, 3. It's not super difficult, right? You're just running some very simple regression models in order to get what you want to do. Now, obviously, as these models start to get more elaborate, right? In my stat class, my second stat class, we had to go through like establishing more complex path models in regression. And then that's a whole like puzzle of going through and establishing that. We just wouldn't do that. We just use an SEM approach or process right now to kind of make that easier. But sort of in the very simple case, this is what we're looking at in terms of stacking these out with some basic regression models. Questions about this procedure? All right. So in this case, Jayla, as you pointed out, old school, like if this was the 80s, right? What I would do is I would just say, well, mediation. We went from something that was statistically significant to now it's gone. Support utilization completely determines the relation between PTSD severity and reported social support. That'd be questionable. You're not going to get away with that today, right? But just as a demonstration of how we would go through and calculate a Sobel standard error for this, remember that here's our formula for Sobel. All we need to do is start plugging values into our formula. Okay. So here we've got my unstandardized coefficient for my A path, 0.251. Here's the standard error. Unstandardized coefficient for my B path, standard error. Just plug those back into my model here. Or to my equation here. And I get a Sobel standard error of 0.003. So what I do is I say Z is equal to AB divided by my standard error, A 0.251, B negative 0.084, multiply those, divide that, I get a Z of 7, right, which is obviously massive. Very, very tiny p-value S space factor. So go through, interpret that like we normally would, right? And what I would say here is I have sort of evidence for an indirect effect, and then these would be my statistics to support that. Yeah.
You just get the P by using that graph pad calculator from.
What's that now?
You can just get the P by using the graph pad calculator.
Yeah. That number's not gonna be on your Z table, so yeah, you just go through, use online calculators for that. Or if you wanted to, you can just set up Excel to give that for you. Yep. And then if you wanted to just drop that in there and then sort of have that crank out your S and your BFB like you all are Excel masters at this point, right? So hopefully you're finding these spreadsheets and probably will useful down the road because it's nice to just drop that. You bet, oh, I got something. I've got a paper. They didn't report this. I can just throw in the values that they have and sort of crank out whatever I want without having to go back through and search through your slides for sort of specific formula and things along those lines. All right. People understand or are comfortable with kind of the process for how we're going through and getting these estimates. Any questions about how we would run a simple mediation based on so what we're presenting here? All right. So we spent a lot of time talking about sort of this causal effects model, okay, or this causal steps model. There are a number of limitations to this conceptually, practically, right, that you want to be aware of as you're trying to navigate these types of analyses. First one is causality, okay? Always, always, always be careful. Anytime you see something in statistics that's called like a causal effects model or sort of causal this or sort of directional anything, is it's probably not. Right? That's very, very hard to sort of tease out empirically, even if that's sort of the name that's attached to it. And so causal steps in this case with the original sort of Judd McKinney, Barron and Kenny conceptualizations, it's a theoretical causal, not actually establishing causality here, okay? Experimental designs, providing more rigorous tests of mediation. We'll have one of these in your problem set. I sort of hijacked some data from Ben, right? Here I can go through where I can randomize control factors, I can manipulate things. And so traditionally, right, this experimental design has been sort of our basis in psychological science for claiming causality. But even if you get deep into this literature, there's people who will get like real upset if you start talking about like I've demonstrated anything causes anything, right? So we have to be very careful with this, okay? And particularly if we're using correlational designs, which for us is almost always when this is coming up, okay? If I have longitudinal assessments, this helps, right? Because I can say, well, certainly X preceded Y, and so Y can't be a cause of X because the thing in the future can't cause the thing that happened today, although even there, philosophically, statistically, we can get into some debate about some things, but at least we're in stronger ground if we have longitudinal data, because I can say I measured this thing today and it's predicting this thing down the road, and that's why this thing is X and that thing is Y, because it doesn't make sense to switch it around, right? But that's not sort of, there's so many different factors that can go in. Even if I measured this today and that thing down the road, if we're doing prospective types of associations, it's still not enough to say that this causes that outcome, right? So again, if they're using correlational data, we can use this to establish maybe plausible models for how this might lay out. But we need to be very, very, very careful that you never, even though we're implying a causal relation, we would never say that. It's a game we play, but it starts to become important so that you're not overstating your effects. Other thing too that starts to get tricky, right? Is again, on the surface, it seems reasonable to suggest that if I'm gonna talk about a causal path, I need to have an initial relation between X and Y before I can start talking about the mediation of X and Y. Because if X and Y aren't related to one another, then it's hard to make an argument for why we're talking about sort of mechanisms of the relation between X and Y if the relation between X and Y is zero. Okay. So conceptually makes some sense. From an applied standpoint, it starts to become a little bit tricky, right? And probably overly stringent. Okay. Now, if I'm measuring X and Y close in time, there probably should be an association present. Okay. William, if you go through and you measure drinking behavior right now and drinking problems right now, those two things should probably be related. If they're not, you're going to be in a tough spot to start making an argument about like, oh, this is why I'm jumping into a mediation analysis. Okay. Now I will say, William, is your data the end all be all of all things in the universe? No. Okay. So there may be other reasons to expect why an effect may be present, even if you didn't quite detect things. But in general, if you run into something that you don't finding nothing on this, please don't stop your problem set. Think carefully about what might be going on with this. So I don't have to dock you a bunch of points. Like there was nothing there, so I just pulled the plug and didn't move forward with anything. I didn't think follow up and asking about whether or not that was a good idea. But again, if X and Y are sort of measured in proximal sort of approximately one another, we should see an effect there. Okay. But as this process becomes more distal, that relation between X and Y may start to get smaller and smaller for a lot of other things. Okay. There could be transmission through other stuff, right? As the relation, the thing that I measured today and the thing that I'm measuring later on, or should I say at the end of the semester, that whatever causes that relation. So if there's other factors that can start to come in and play in and start to influence the strength of that association, right? I could have competing processes. Sort of some things make this really strengthen this association. Other things reduce that association. It's not that X and Y aren't related to one another. It's being influenced by different things in ways that can kind of cancel each other out. So that if I'm just looking at the bivariate relation between X today and Y at the end of the semester, I may find that association is pretty weak, maybe not even there, right? We can also have random error, right? There's just stuff that comes up, right? And so we start to think about reliability of measurements, things along those lines, right? And so we also have situations where my ability to detect causal processes starts to be better than direct effects on X and Y. Okay. So let's say that A and B, sort of path A and B, consistent with medium size effects, 0.3. Okay. Right. If I were to go through and run a power analysis, how many observations do I need to detect sort of path A and path B? Well, if the effect size we're just using correlation here is 0.3, I need only about 80 people in order to reliably detect that effect. Okay. So in this situation, if the relation between PTSD and utilization is 0.3, utilization and support is 0.3, if I've got a sample of 80, I'm well powered to detect those effects. Okay. But if utilization completely mediates that association, meaning that the direct or C prime path here between PTSD and support after I account for utilization, right, is literally equal to zero, then my bivariate association of X and Y here is going to be 0.9, right? So you got 0.3 by 0.3, right? AB plus C prime, A times B is 0.09 and C prime is zero. What this is saying is the correlation between X and Y in this case is going to be 0.09. Okay. Here I need almost 1,000 people to be able to detect that. So we can very quickly find situations where, and maybe I know that PTSD is related to support because that's been demonstrated again and again and again and again. But in my data, if this path is 0.3 and that path is 0.3, by definition, it means the bivariate is, and if there's no C prime, if that's literally zero, it means the correlation I would expect between PTSD and support to be 0.09. I need 1 billion people in order to detect that, right? So there's situations where you may have indirect paths, you just don't have the power to detect the direct association, which seems weird and counterintuitive, but very much can happen in this situation. So the idea behind all of this, and I sort of really want to drive this home, so if it's this, the who cares, is thinking about this causal effects approach or this causal steps approach starts to become limiting in that it's requiring this initial relation between X and Y. There's a lot of reasons conceptually, mathematically, where we might not be able to detect that X-Y relation on the front. It doesn't necessarily mean that there aren't intervening paths or sort of indirect paths there to be had. You kind of getting the idea behind that. Okay. Again, this just starts to become really, really critical when you're thinking about if you're wanting to do these types of models, knowing kind of the nuts and bolts and how this stuff fits together, because it can be start to become critical for you defending your research or critically evaluating other people who've gone through and done this. All right. Another thing that can happen is what we might end up seeing is something in this Trout and Bolger paper or Bolger paper is sort of he's labeling as suppression effects. Suppressor effects are different than the suppressor effects you might see otherwise in the regression literature. But what we're talking about here is a situation where the indirect effect of A and B has the opposite and sort of equal magnitude as the valence of the direct effect. Okay. So let's say we've got a situation where coping behavior is our mediator, however we're defining coping behavior. Okay. And coping behavior is activated by environmental stress, which is supposed to be associated positively with psychological distress. Okay. So in this situation, we've got environmental stress and coping holding a positive association. Okay. As my stress goes up, my coping goes up. If I don't have a stressor, I don't have to use coping mechanisms because my coping is not needed. But as my environmental stress goes up, as the semester in graduate school increases, your coping increases, right? Because you've got more stressors to address. Okay. But I would also expect coping and psychological distress to hold a negative effect. Okay. As my coping increases, assuming it's sort of effective coping, my stress level should go down. Okay. And so because of this, if path A is positive, path B is negative, the product of A, B is going to give me a negative value. Makes some sense. So I have a negative indirect effect here. But in this simple regression model or this simple mediation model, because the total effect of X on Y is equal to AB plus C prime, what you could find is a near zero association between X and Y if whatever this residual association here, the relation between increased stress and increased distress, if this C prime path is so the relation between stress and negative stress and environmental stress and psychological stress should be positive, right? If C prime is about the same size, but in an opposite valence of what your indirect path is, if I take my negative indirect, let's say this AB path is negative 0.3, and if C prime is positive 0.3, if I take negative 0.3 and add it to positive 0.3, what's the direct effect that I'm going to observe just between X and Y? It's going to be zero, right? So if I just look in these data, whether or not I'm seeing a relation between X and Y, what am I going to conclude? It's not there, right? When in actual fact, you may have a very important relation, sort of a dynamic system going on here, where what you've got is an indirect path that's marked by sort of an indirect path valence in one direction, and whatever is left over here is going in the opposite direction. if you're not working on this model, it just looks like nothing's related to anything, right? But what it is just sort of specific, it's kind of like a perfect storm where everything is kind of just nulled itself out, okay? Also, the same thing, it's not unlike in moderation. I look at the relation of X and Y, right? And I find that sort of just if I look at the bivariate relation, nothing going on here, right? If I actually look, let's think about, oh, there's a moderator going on. For one group, I've got this. For the other group, I've got this. If I don't model that moderator in there, what's the relation between X and Y? 0. But as soon as I go through and include that in there, now all of a sudden, there's something very interesting happening within this, right? So again, I can't emphasize enough how important it is not just to be cranking things out in SPSS or R or Stata or anything like that, to be thinking carefully about what am I looking at? How are these how are these things sort of playing out? And if you start to find null effects, sort of recognizing that that null effect may be a product of very interesting things that are going on that just aren't modeled correctly. Okay. Questions about this idea of suppressor effects? This is just like basic 5th grade algebra. It's just sort of a positive and negative of the same magnitude to cancel each other out, right? That doesn't mean there's nothing going on. It just means that you've got an artifact of sort of some indirect effects here. Okay, so for our a priori effects, recommendations, okay? If you have things that are measured very closely in time, okay, you should probably expect those things to be related. If I've measured both things concurrently at the same time and I'm not seeing an association, it's going to be hard unless you've got a good reason. There are good reasons, but it's going to be a tougher row to hoe to make the argument for running a mediation analysis if X and Y aren't related, particularly if you've measured them really close in time. Okay, and just having that baseline relation between X and Y is just going to make your life easier. Okay. Now, if you're measuring things prospectively, more distally, right? These are situations where this initial relation between X and Y may be not having a harder time detecting that, but if you're prospectively evaluating things, there's sort of ways you can go through and make that argument. Okay. If you're expecting subtle effects of X on Y, right? Again, going back to that, sort of what I'm saying is I've got an okay relation here, an okay relation here. But if I'm thinking that this really is accounting for, by and large, the bulk of that relation between X and Y, you just might not have the power to detect that, right? Which is an argument that could be made. Or possible suppressor effects, right? So AB is the opposite sign in equal magnitude, as that should be, oops, that should be C prime here. Cindy, can you shoot me an email real quick and tell me to fix this slide? This should be C prime. Thank you. Okay. So these are situations where wanting to think about from a causal steps approach, the idea is that you should see X and Y be related to one another. And probably this is the case. And it makes your life easier if that is the case, right? But if it's not, you're not done so, right? There are situations that you sort of may point to say, we're still sort of going to continue with this model because there are reasons why we might understand sort of this absence of being able to detect this effect because of X, Y, or Z. All right, let's take a break there and jump back in. Take 10 and we'll jump back in with some standard error stuff. Okay, so in terms of sort of issues with Sobel, or excuse me, of causal steps, getting a little bit, being okay, being flexible with this sort of need to have this a priori association between X and Y. Okay. Another limitation, though, mathematically, statistically, with causal steps, ends up being some stuff going on with our standard errors, okay? Our Sobel test doesn't give us appropriate standard errors for this indirect effect. Remember I said Sobel was an approximation, okay? And the reason it's an approximation is because the sampling distribution of AB isn't normal, okay? And Sobel is a standard normal theory test, but what we're doing is we're applying a standard with Sobel is we're applying a standard normal theory test to a distribution that's not normal, and so it's not precise, okay? It's good, but there are situations where it starts to fall apart, okay? So what we've got here, when we actually look at the empirical distribution of AB, what we see is that it's non-normal. And so what happens is when we go through and we calculate our Sobel standard error using the Sobel formula, it gives us a normal theory standard error estimate when the distribution that we're actually looking at is not normal, it's skewed, okay? If I have positive indirect effects, I'm going to have positive, the sampling distribution is going to have some positive skew, negative indirects, it's going to have a negative skew, okay? So what we've got, so as we're demonstrating here, we've got a sampling distribution that's skewed, and we're superimposing a normal curve on that. And so our standard error estimates are only an approximation, they're not precise, okay? And so what happens then is our Sobel tests start to become underpowered, which is problematic because we're already worried about underpowering stuff, right? In most cases, except for those, if I have a really large sample size, I'm generally pretty good. Sobel will probably do a good enough job if I got a really large sample, or if my indirect effects are really large, okay? This we can do sometimes. This is a real gamble because anytime we're looking at indirect effects, unless it's something very clear and obvious, and generally not the types of things that will probably land a publication for demonstrating very clear and obvious things, right? We often label clear and obvious things as fairly or unfairly as not interesting, right? We're generally looking at, I know, right? It's like, Beck, hey, here's the thing, Beck. Yeah, no joke. Right? We already knew that. We didn't need to attach a p-value to that. So all of a sudden now my Sobel starts to fall short. Okay. There's some variance on Sobel, but still sort of limited in those regards. And so this extends my confidence intervals around my indirect effect. Again, because I use that standard error to get them confidence intervals sort of derived from Sobel start to become problematic as well. Okay. So the problem is my sampling distribution of this AB statistic is not normal, but Sobel is using a normal theory curve to put on there. And so it just doesn't match up. Okay. It would be like the same thing as back. I'm deriving p values from Z when I'm using a t-test, and the sampling distribution of t doesn't follow Z until the samples get really large. That's why we don't use it. Same problem here going on with Sobel. Okay. So our solution here, and this is something that's become more and more common. This has been around for a long time. It's just you need to have the computing power to do it because doing it by hand would be very burdensome. Is what we would call bootstrapping procedures. Okay. Who here is sort of familiar with bootstrapping? Have heard about bootstrapping? Ish a little bit. Have heard it as a term kind of thrown around. Okay. The idea behind bootstrapping is it's a resampling procedure. Okay. And with this, what we're going to do is we're going to generate an empirical distribution of some parameter, right? So we have certain statistics that we actually don't have a theoretical model for what that sampling distribution should look like. For Z, for T, for chi-square, all that, we know if we've not violated our assumptions, we know exactly what that distribution will look like down to very, very precise limits. But there are some things that we don't know what the sampling distribution will look like because it's non-normal, it's unpredictable. What we can do is we can go through and we can create what we call an empirical distribution of some coefficient. And what we would do here is we would go through and take sort of the data that we have, and we would sample from that data set and calculate our estimate. And then we would do that again and again and again and again and again with replication. And what we would eventually end up with is an empirically derived distribution that we could then use to go through and calculate some effects. Okay. So, and again, this bootstrapping procedures, and there are different variations. These are recognized as our best practice methods for evaluating mediation stuff. Okay. So again, what we're doing is we're taking our observed data. Let's say here in this example, we had 200, 300 some people. Okay. If we're going to bootstrap this, what we're going to do is we're going to say, here is my population. This set of, say, 300 cases, this is the population. This is everybody. Okay. And what we're going to do is we're going to take a bootstrap sample of if I have 300 observations of my data, I'm going to take a bootstrap sample of 300. Okay. But what I'm doing is I'm choosing with that bootstrap sample, I'm choosing 300 cases from my set of 300, but I'm doing this randomly with replacement. Okay. This seems a little bit strange. If I have a set of 300, that's my population, how am I taking the sample of 300 and getting a different thing than if I were to just ran in the first place, right? But with the bootstrap sample, let's say you all are my population, right? And I go through and I'm going to take a bootstrap sample, right? And I go through and I pick Jack, right? Jack's one person. I throw Jack back. I'm going to, there's 7 of you, right? So I'm going to do a bootstrap sample of 7, right? I go through, Jack's my first person, throw Jack back. Pull another one, Jack's back. So now I got Jack again, throw Jack. Get Cindy, Cindy's in there. Jack again, Cindy. I could have a whole sample that's just versions of Cindy and Jack, right? And that's my bootstrap sample. And maybe my Cindy Jack sample, my parameter there is kind of way out here because I just got the same 2 people over and over again. But that's fine. That represents the end of the distribution, right? And so now that's a silly example with just you all, but we would do the same thing with our data set. We've got 300 observations in my data set. I'm going to repeatedly draw random samples of 300 with replacement. And every single sample I draw is just going to be a little bit different. Okay. And what I'm going to do then with each one of those draws, I'm going to go through and I'm going to evaluate AB independently within that sample, right? And then I'm going to do it again and again and again and again and again and again and again. Okay. Let's say set this to 5,000. Okay. And what I'm going to end up with is a sampling distribution, an empirical distribution where I create a histogram of all of those AB estimates. Okay. And what I can do then is use that distribution to then go through and generate the standard error of that distribution, which is my standard error for my AB coefficient. Okay. So again, the distribution of my AB values across however many replications, this is the basis for generating my standard errors, my confidence intervals. The standard deviation of AB, that's my standard error. So recognizing given that AB, that sampling distribution is skewed. Same thing when we're going through and we're calculating confidence bounds around estimates of effect size. Those can be not symmetrical. Same thing here with our confidence intervals. So one side will be a little bit bigger than the other with AB. Okay. So basically what we would do is I would go through and okay, here's my sampling distribution of AB. It's non-normal on purpose, right? And Katie, if I wanted to get a 95% confidence bound for AB, how would I calculate that based on this empirical distribution that I've created here? Where would I know my upper and lower limits are in ideas? I want to create, let's say, a 95% confidence bound around AB. What could I do? So if I want 95% of confidence around, I'm wanting sort of things to capture to the middle 95%. So how much of the top do I cut off?
0.025.
What's that?
0.025.
Yep. So here's the bottom 2.5%. And what about this?
Same thing.
Same thing,
Yeah.
2.5%. Whatever this value is and whatever that value is, the empirical distribution, there's my lower bound, and there's my upper bound. Okay. What we're doing is we're going through and with the data that we have, we're going through and we're saying this is what the sampling distribution of AV is, right? And whatever the lowest bottom is, so we go through and take that, that's my low bound for my confidence bound for AV. Here's my upper bound. And then whatever the standard deviation is here, that's my standard error. So instead of relying on a theoretical distribution like T, Z, F, chi-square, things along those lines, what we're doing is we're just creating a distribution and saying, we're assuming that whatever the population distribution of this affected or this coefficient is, basically kind of capture the shape and things like that. And then we're going to go through it and set this. Okay. Now, if I were to go through and let's say, Jayla, you go through and run this. Okay, you run 5,000 bootstrap samples. You go through and do this. You get a standard error estimate, get a lower and upper bound for your empirically derived confidence interval for AB. And let's say Catherine does it, right? It's the same set of data, but she draws her own independent samples of 5,000. Are you going to get the exact same answer? No, it's going to be a little bit different. Should it be very close? It should be very close. And if we've got if I've got a big set and I'm running a lot of replications, if I were to sort of run this analysis once and then do it again, and do it again, and do it again, should I see much movement in those parameters? Probably not, right? But this is why for when we're doing this in this mediation set, if you don't get the exact same numbers as your neighbor, that's an okay thing because we're generating empirically an empirically derived distribution for this. People get the idea behind bootstrapping because then what we've done is we've created a skewed distribution because that's what the sampling distribution of AB. But instead of relying on Sobel and superimposing a normal curve on this, saying here are the upper and lower bounds and here is the standard error of this or the standard deviation of the sampling distribution, we just create one based on the data that we have and then sort of go through and calculate from there. You've kind of seen the kind of the process for what we're doing with this. Is bootstrapping a solve all for everything? No, William, why not?
Oh, I was just guessing.
Okay.
Maybe just because like, I mean, it's kind of like a hypothetical distribution. So like, I don't know, and it's based on your data. So if there's like any sort of error with your data in general.
Yeah. Your bootstrapping procedure is only as good as your data. If you feel like you have good representative data and sort of a good sampling of the people who you're targeting and want to do, this can be a great way to go through and address things, right? But if I got a real garbage sample that's not representative of who I'm actually trying to get, does it matter how many times I sample that garbage data set? No, right? It's going to be all biased and off, right? What will happen is people will misunderstand kind of what's going on. And there are different ways in different areas where people will like, I have a small sample, so I'm just going to bootstrap this and run like a bootstrap test for this based on the sample that I've got and assume that that's a fix. It's something that you can do. But if your data is not any good, it doesn't matter. It's not a magical fix, right? So wanting to think carefully. If you see that someone has bootstrapped something, so wanting to be careful, like, is their sample any good? Who are they trying to generalize to? Yeah.
Is there like a minimum sample size you need before you can consider bootstrapping?
Well, this is the thing. In some areas, sort of with sort of more basic statistics and things like that, people will have very, very small samples, and we use bootstrapping as a strategy to go through and sort of generate estimates and things like that, as opposed to just the means. And so there are ways to use this appropriately, and also ways to misuse it. So we don't see a lot of bootstrapped analysis in behavioral sciences. It's not just something, but in wildlife, bio, stuff like that, you'll see this sometimes, right? And it's a way to address smaller samples, but just need to know pros and cons and limitations of it. No magic bullets. All right. So Um. Obviously, to sit down and crank out 5,000 replications in your own data set by hand is not something that anybody is gonna do. You don't have time to do that. But thankfully, sort of with advent of computing power and things along those lines, this starts to become so much more accessible to you all than it would have been for, say, me when I first started out with stuff. Um, yeah, the first time I did this, I was doing it in M plus because you could do that in an SEM environment, sort of. But now process is kind of the big tool that people will use. Does anybody use process? Familiar with process? Yeah. What do we just with papers and stuff like that, Kitty?
Yeah, I've done a lot of the like analyses I've done for my undergrad research and even stuff for Jared. We use process a lot. So.
Yeah. Process is a fantastic tool. Process is a macro that goes through and runs a number of different analyses with standard statistical software that you used to have to do in like SEM environments and things along those lines. Process will go through and use OLS regression to run sort of different path models and things along those lines, provide a whole lot of outstanding and excellent statistics, right? It makes it accessible and sort of reduces burden on users to sort of have to go through and try and set up and having like the intimate technical knowledge of how to go through and set some of this stuff up, which is awesome. Okay. It also has bootstrapping features and things along those lines to make your life easier. It's all bundled and sort of packaged up. It's a cool tool. Okay. And it's something that can be misused a lot of times if people don't understand what they're using it for or underlying assumptions. If you start to look through so the number of the different types of models that process run, it's kind of like prepackaged sort of different things. They're brilliant and they're cool and they can be used to identify a lot of different relations between things. But your method section should never be I use process model X. Part of that, but then also you need to describe why, what's the rationale, why that one, and things along those lines, because stuff starts to get pretty elaborate. Okay. But what's nice is this is a macro that you can go through and download. Okay. And once you do it, all you need to do is just one line of code and that will go through and run your model for you. Okay. So the way this is set up for our model here, we got process Y equals whatever your outcome is here at support, X equals PTSD, that's my independent variable or my predictor. My mediator in this case is utilization. So putting that in. Total equals 1. This is giving me my total effects on X and Y. Sort of this is, and there are lots of other sort of things you can add on if you want to go through and get in the weeds with this model. This is important. This is telling me which model you're going to use. And in process, it's got like pages and pages of different models, looking at moderation, mediation, conditional indirect effects models, like sort of all sorts of elaborate stuff. They're just like random, like sort of specifying different configurations that someone might want to go through and use and take a look at, right? You just have to know which one you're using, why, and sort of have good arguments for why that is an interesting and sort of meaningful thing to run on your data. Here I've got at the end, normal equals 1. This is just giving me Sobel test for my outcome program. But there's lots of other things you can do. So here you can sort of spec on, if your default bootstrap is 5,000, you'd say boot equals whatever it is. That'll just sort of, if you wanted 10,000 replications, you could do that. You don't need to, but if you did, right, go through and do this. So if you specify CONF, it's going to tell you where you want your confidence intervals to be, right? If you default is 95, but if you want a 99 or something different, you can go through and drop that in there. Total equals 1. This gives you total effects of X on Y, normal. F size, this gives you estimates of the effect sizes for your indirect effect. This starts to get tricky. It's not really good. We don't have good effect sizes for your indirect effect, particularly as your models start to get more complicated. There are ones that have been proposed, but there are just problems with them. It's not something sweet like D or R or eta squared that has a nice intuitive thing, like there's problems, so. It has an option, but there's some limitations just methodologically, we haven't quite caught up with that. Contrast, here we're gonna look at, looking at, so your indirect effects, is this indirect effect stronger than that indirect effect? Go through and test that for you. Here, if you, hit center equals 1, it'll sort of just mean center everything for you, right? So there's lots of different things that you can go through and do. We're not gonna get into, because we don't have the time. Like, you could do a whole class on process, right? We're gonna use it, I'm gonna sort of have you use it just to estimate a very simple mediation analyses, right? But in your labs, in your work, you may have an opportunity to go through and sort of use this. It's a canned package, right? But so long as you have a question that fits sort of those models, or those, those kind of models that are sort of specified in there, which is most things, it's an incredibly useful tool. Just know what you're using online. Don't just like, oh, I ran sort of this line of code and then I'm reporting whatever nonsense comes out the back end because I screwed something up. Okay. Questions about process? No.
I guess more just like what's the difference between this and like the built-in bootstrapping functions on like SPSS, for example?
I'm not sure sort of what I haven't kept up with SPSS and kind of what SPSS is doing and stuff like that. The other thing too is process is a macro. So every time you open it up, I'll show you, it's just a syntax file that you just run the whole thing and it kind of loads it up. You can also go through and set things up so that it's just kind of loaded up into your version of SPSS. So you don't have to keep running it over and over again. And then there's some pull down menus and stuff like that, right? Andrew Hayes has got like his whole lab is built on sort of developing these macros. And it's incredibly helpful and useful. Not sure exactly what SPSS is doing. What I like about this is it's a known entity done by a trusted person and a trusted methodologist with lots of evidence out there. Sometimes SPSS can be a little bit of a black box in terms of what they're thinking. Oh, hey, here it's this. And it's easy to grab and say like, oh, I did this with SPSS. So I'm not 100% sure. Probably it's fine, but who knows? There's errors. SPSS has errors and stuff like that, and they've been that way forever and ever that are just known, right? So want to be careful with that a little bit. Okay, so wanted to go through, and you probably can't see this on your screen or on this screen necessarily, but hopefully on your own screen here. This is output from process, okay? And here are our sort of 3 models that we ran in just in SPSS, right? So here at the top of your process output, you're saying model is for support is your outcome variable, X is PTSD, your mediator is utilization, sample size 304, okay? Always check that to make sure that this is, yes, what I want you to be running, okay? Then what we have is sort of this sectioned out. Your first model here is going to be the regression. So this is estimating path A. This is the regression of support onto PTSD. Here's the thing I will tell you. Process is not doing anything useful or unique or different than you would do on your own, except for that standard error piece. Everything else is just OLS regression, the exact same thing you would get if you were just doing this by hand, okay? And if you go through and you take a look at your first, sort of here, your coefficient for PTSD is 0.209, 2509, it's the same thing here, right?
Path A and C are flipped.
What's that?
I believe, oh no, on the R1, it's flipped. On R1,
Okay,
just,
can you send me to fix that for you? Yes, sorry about that if those are flipped around. Okay, yeah, here we got path A. Should be path A. Make a note of that. Because this is looking at the relation of utilization as your outcome variable, PTSD, right? So mapping onto here. And so we see your coefficient is the same, your p-value is the same, your interval estimates are the same. It's not an accident, it's just because process is just running this model in sort of the macro. Okay. Here, you have your final, what we would say are sort of step 3. This is looking at path B and C prime. You'll see that everything is identical and the same. And if you were looking at your model summary stuff, that would be the same too. Down here, you get to your total effects model. Here, this is just looking at path C. Again, everything's the same. Okay. So all the process is doing is just running this for you. Is no different than what you would already get sort of just running these by hand. Okay. Process is doing nothing special at this point. And then here at the bottom, what it's giving you is you'll see total direct and indirect effects of X on Y. Okay. Total effects of X on Y, that's just path C. You already got that. It's just laying it out for you. Direct effect of X on Y. This is your partial effect controlling for your mediator. Again, this is just C prime, right? There's nothing useful going on here. Like this piece of the entire output is the only thing that's different than what you would just get from your standard regression models that we ran. Okay. Here is your indirect effect of X on Y through utilization. Okay. This coefficient is just AB. That's no different than the one we calculated over here. Okay. Here, though, you got your bootstrap standard error. Okay. This is the estimate that process generated from 5,000 replications with resampling, given the data we have. Okay. Can someone tell me what was our Sobel standard error for bootstrap standard error? Yeah, that. Yeah, what was it?
0.003.
0.003.
Yeah.
Okay, so here it's 0.0034, right? William, if I were to run process again, if I were to run that model again, would I get the exact same value here? No, right? And also sort of that model that we ran, so that was kind of rounding by hand. This is going to be a little bit more precise, right? Also, we have a really big sample, so Bell's probably going to be okay in this situation, right? So we're not getting anything too different, but this is the only thing right here that's happening. And I guess here, if we go down through and take a look, here is your normal theory. This is just your Sobel. And it looks like if we would have calculated this out to however many decimals process is doing it, we're getting 0.0035. It's 0.0034. That's a trivial difference. It's not going to make any difference, right? But again, we got about 300 people in this, a little over 300 people in this sample. So Sobel's actually not performing too bad in this situation. Okay. But if we start to have situations where we have smaller sample sizes, we're going to start to see differences here. So again, here's the thing. Process is an amazing tool, but it's not magical. Okay. The only thing out of this full output that we're getting that's unique or different than what you would just get like running those 3 separate models is just these values right here. Okay. So just know that, right? This is good. And this is, anytime you're doing this, this is probably the approach that you should use. If you're using Sobel, someone's like, why are you using Sobel? And you're like, well, I got a lot of people. It doesn't matter. I just ran it here. They'll still probably tell you to go back there and use process or bootstrap. It won't matter, but it's just best practices approach. Okay. But if you start to get smaller samples, you will start to notice some of the problems that we see with the derivation of those standard errors. Want to see how this works in actual real life? Has anybody used macros in SPSS or anything along those lines? Super easy. I don't use them outside of this either, but if we go through and pull up sort of this data set, right? So here's this SPSS set that has our support utilization PTSD stuff. Okay. Did I post the SPSS or the process macro? Okay, I'll go through and do that. Okay. So I got two syntax files here, okay? And here's my sort of full sort of data set. I will send you a copy of the process macro. It is a massive, 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 massive file, okay? The good news is you do not touch or change or modify this file in any way, okay? What you do is you open it up with your data set and then you say Control A, or whatever weird Apple version of that you have. And then you just go through and hit run. And it runs that macro, okay? What that does is that just loads process up and so it's ready to roll, okay? Then all you need to do is go through and write your one line of code. And what that's gonna do is it's gonna give you the stuff that we saw in the slides, okay? So here, what I could do is I could run this, right? And it's gonna give me sort of my output. So we've already gone through and looked at this for these data. What I'm gonna do is I'm gonna run this line of code, right, that I set up, so that we talked about in that thing. And I'm just gonna hit run. And it pops it out for you. Okay. And if we go through and we take a look at my standard error in this run versus that run, or the one that we had on in slides, my standard error is identical. Oh, so we're getting, this has got more stuff going in it than what we did before, but you know, my bootstrap standard error 0.0034, 0.0035, so that came out the same, probably because we got a lot of people. This is going to be a really stable estimate, but probably what we would see is minor changes in sort of the upper and lower limit, just sort of due to just random variations. Yeah. So this is why people love process, is because it's really, really easy to just go through and run. You just have to make sure your model statement is in there correct, and then you just run that, and it gives you everything you want, right? Just up to you to know what these things mean, how to interpret them, and making sure the model that you're running is correctly specified and consistent with something that makes conceptual sense. Questions about process, how to use process, anything like that? Okay. Process, you can also use this process to run moderations. Just got a moderation model, you go through and do that, right? We're going to spend a lot of time walking through the nuts and bolts of how to do this without a macro. And I think that's important because give you some exposure to how to go through it and sort of think about interpretations, navigating, manipulating sort of equations and things along those lines. But when we get to that section, if you wanted to just go through and crank out sort of your simple slopes and sort of all your analyses, and then also run it in process just to see if you got the same stuff, you should get the exact same thing. Because here in mediation, process will give you that bootstrap standard error that is sort of unique that you can't get just in SPSS on its own. For moderation, it's doing nothing other than just simplifying. It's the same thing that you would get. I had a paper come, or sort of a review one time, like I don't use process for moderation because I don't need to, because I know that I'm just comfortable sort of setting those models up, and had a reviewer back, well, you didn't use process. It would be like someone like yelling at William, I'm sort of going to reject your paper because you didn't use SPSS, you used R instead, right? Like, it does not matter. It does not matter. So I just have to explain to people that that's not something we need to get caught up and worry about, right? Yeah, and a really excellent tool and something that we can start to use, look at more elaborate models with, okay? And so if we look at what that looks like, you know, this is sort of building in moderation mediation because we normally talk about, we usually do moderation first and then mediation, but we go through and start thinking about moderation with higher order terms, mediation with covariates, right? We've talked about mediation with a very, very simple basic model. And honestly, at this stage of the game, it would probably be hard to get like a simple 3 variable mediation like that published just because people will be expecting more elaborate things. But that three variable mediation is a nice place to start. Like, here's what I think is going on. How might I go through and elaborate on that, right? So you're gonna have multiple mediators, moderated mediation, mediated moderation. A lot of this language has gotten sort of stripped out because mathematically these are identical, right? There's some interpretive things. Hayes and some of the language that he's introduced is this idea of conditional indirect effects. We talked about that as sort of maybe why I have a residual effect of X on Y is because this indirect effect that I've identified is maybe not constant for all members of my population. Maybe there are certain individuals where that indirect effect gets stronger or weaker. We can go through and model in those moderators, and now we've got what Hayes would refer to. So traditionally, this idea of moderated mediation. Hayes just says, like, let's not worry about sort of the tech. It's a conditional indirect effect. This indirect effect is conditioned on some other variable. So go through and take a look at that. So, just sort of reporting on regression analyses, the types of things you should go through and so be thinking of include in publications. Want to have mean standard deviations. Cindy and I have discussed about some jerk. Publishing papers not reporting means and standard deviations. That's a headache, right? Correlations, right? It's good to have a correlation table somewhere in there so people can just look at the bivariate correlations, right? That's super useful if you go through back. I don't care about your model. William, you published a paper, but you did measure this and this. I just want to see what those things are related to one another. Just publish your correlation table so go through and see that, right? Your model R squared, standardized coefficients. This is nice in text. I generally put these in text with the associated p-value, right? Just because I can go through and take a look. Unstandardized coefficients, hard to make some sense about that. Standardized coefficient, I can just look and tell whether that's pretty big, pretty small. But your unstandardized coefficients, those are critical. Want to have those tabled somewhere where people can go through and take a look. Confidence bounds around your unstandardized coefficients. This is helpful to sort of get an estimate for precision. I get in table. And then I have thought about this. We're just working with a lot of different effect sizes. I have tended to gravitate towards squared semipartials and F squared. Squared partials or your partial coefficient is nice because you have benchmarks for sort of small, medium, large, whereas you don't with your squared semipartials. But your partial coefficient is going to look almost identical to your standardized coefficient. And when I put those together in tables, it looks redundant, right? Because I've got here my standardized coefficients and then my partial correlation is almost the same number. I was like, right? So what I've started to do is switch in and just put F squared. That's your formal effect size for regression if you're going through and running power analysis and things like that. So if you just provide that to people, that's a nice boost so they don't have to try to do it themselves, right? And then squared semipartials are just nice because they have good interpretive value, right? But it's hard to sort of determine whether or not there's not good benchmarks for small, medium, large, kind of up to you to determine whether or not that's something useful. All right. Questions on any of this? Feeling okay with mediation? All right. So we've technically finished up with all this, but I would like to give you a little bit of space in between some problem sets with stuff. So we've got a problem set due this Friday. Get that one done. And then give yourself a little bit of breathing room if you want for the mediation set. The mediation set is not difficult. It'll be sort of pretty straightforward, right? Still take time, so you jump on it early. But what we'll do is we'll set the due date for your mediation set, not next week, but the following week. Okay, just to give you some time to sort of go through and do some stuff. It'll take us a little bit to jump through some of the moderation stuff. Yeah.
So just looking at the schedule, between now and spring break, there's 2 problem sets. Or just one?
Probably not. Probably the one that you're doing right now and probably mediation. We probably won't get that. We won't probably are not likely to have moderation covered in enough detail for you to then have time to then go through and do the set. So we'll just go through and we'll play we'll play around with that and just sort of work as it goes. Cool. Sound okay? Yep. Awesome. Here's what I'm gonna suggest. Let's go through and, it's the last period of class, just get a head start on moderation stuff, just to kind of introduce some basic examples and things along those lines. I would love to turn to loose, and also the moderation stuff is, there's a lot to work through with that. So just want to sort of start, we'll use the last, sort of period of time here to just sort of start to go through and get some sort of basic stuff on that. Those slides are not posted to you, is that true? Okay.
I can't proceed further unless I know. I got lucky.
I just emailed that to everybody. Let me know if you got that. Get it? Not yet?
It's just right now, actually.
Josh,
What's that?
sorry, can you remind me what the formula for F squared is? Is it just the square root of T?
The formula for F squared, we haven't covered that. It's in the moderation stuff. You're just taking your partial correlation or your partial correlation over like 1 minus your partial correlation or something along those lines. It's super easy and straightforward. So yeah.
Got it.
Pop in, okay. I like this, anytime you get multiple emails that you've requested from students to say, hey, fix your slides. All right. We won't get too far into this, but just want to get a head start on stuff so that we're not crushed for time on things. So wanting to switch over, so talk about mediation. Moderation, easier to probably make arguments for, but much more complicated to go through and actually run. And sometimes harder to sort of detect given small effects. So what we're going to do is we're going to talk about sort of conceptually what we're talking about in terms of moderation. We're going to get into an issue of centering, which is sort of a fun little thing to do to make your models more interpretable. Talk about multiplicative models, testing simple slopes, standardized models, some moderation with nominal variables, which is kind of cool. Talking about some curvilinear effects, and then talking about effect size, power, and things along those lines. So again, same thing as before, right? With our normal regression, our standard horse race regression, right? We can go through and look at the unique effects of X on Y. And that's cool for a while until it gets to be sort of boring because lots of people have already determined that. And so it's not super interesting, right? And again, this starts to, as we talked about before, it starts our standard regression is limited in how we can go through and start thinking about like how these variables relate to one another. Okay. And so again, a different way, again, say, given we got strong evidence for a relation between these two variables, right? Again, going back to, so the original, like saying like, here is, so like masculine honor and aggression, right? Like certainly we know that those two things are related to one another, but are they related to each other always in the same way for everybody across the board, right? And this is what I think, like, we don't think about, like, I think we sort of think about moderation in cool ways, right? Like, so I think about, like, here's a relation between X and Y. We always talk about the relation between X and Y. Is this the same relation for always and forever under all circumstances from here to the end of time for all people in the entire universe? Probably not, right? There are probably things that start to shift this around, right? And this is where we start to go through and talk about moderation. Like we can start to go through and say, yeah, X is related to Y, but under what conditions? Like under what circumstances do we see this relation? Or are there things where that relation starts to break down, where that relation starts to get stronger, right? So a lot of really, really interesting questions that we can start to go through and sort of thinking about, sure, and under what circumstances, what things might start to change either magnitude or direction of this association that we know and have demonstrated in the literature over and over again. Okay. So if we're talking about moderation, we're talking about a process where we've got some third variable starts to change the association between X and Y. It doesn't account for it, it just starts to change it. Okay. So again, in this situation within this model, our moderator is some variable that's either affects the magnitude or the direction of the association between X and some outcome. Okay. So here we've got not sort of X leading to M and M leading to Y. Here we've got the relation between X and Y. We're not worried about why X and Y are related to one another necessarily, although that could be an interesting thing that sort of leads into some mediation stuff. Here we're saying, does this change based on, does this association change based on some other factor? So again, one of the things we say, the impact of stress on physical health depends on the degree of social support available to the individual, right? I'm stressed, how does that impact my health? Do I have people around to help me, right? So if I can, like, it's a grad school, right? Like sort of how is sort of the stress of grad school impacting your health? If you're going it alone and you don't have a lot of support, that's probably going to be pretty taxing. If you have a good group of people sort of around you who are sort of like helping you move through this, maybe it's not nothing, but maybe it's much less tightly related than sort of if you're kind of a lone wolf out there in the universe. Okay. What's the relation between pathological and psychological distress and substance use, or the relation between psychological distress, substance use differs across men and women? You know, maybe, I don't know, is this true, William? Do we see sex differences in the way, in the relation between distress and alcohol use?
Depends on how you measure consequences.
So maybe, right? So maybe what we're seeing is for different people, sort of this association looks differently. For some, it might be very strong, and for others, it might be not there, but maybe less strong in a systematic way, right? These are the types of things that we're going through and looking at within the context of moderation, okay? And so again, look at this, circle this, sort of tattoo it on your arm if you want, that'd be awesome. Like moderation, looking at the condition under which an association is strengthened or weakened, right? And in this situation, we would say that the relation of X and Y is conditioned on M. Okay, really want you to like sort of take note of this terminology. we're talking about a conditional association, not any different than what we talked about previously in like factorial ANOVA. We're saying that the relation of X and Y is conditioned on M. It depends on M. If Jack, you say, hey, how is X and Y related? If it's a moderated effect, I don't know. I have to know the level of M. If I know the level of M, then I can tell you how X and Y are related. But aside from that, I don't know. It's a more complicated question than what you're actually asking here, because we've got a conditioned effect. And a conditioned effect being different than a conditional effect, because then that's sort of just your partial stuff. So we'll try to keep that sort of separate. Okay. So basically what we're talking about is interactions. Okay. And historically what we've done is we've gone through and looked at these in ANOVA, right? So we're looking at the sort of interaction of sex and ethnicity on social bonding. And let's say we have sort of reason to believe, sort of based on socialization and sort of cultural background, sort of that there are maybe differences in how we see sort of that manifest in terms of the relationships that we have, right? We just call this a 2x2 ANOVA. Yeah, sort of what we might sort of identify or conceptualize as sort of nominal variables and how this relates to a continuous outcome. Just go through and do that with an ANOVA, right? But sometimes what we're interested in looking at interactions that involve continuous variables, okay? Let's look at sort of sex differences and SES on institutional salary, right? Now I could go through and I could dichotomize or sort of mean or median split SES and see how men and women sort of whether what differences we're seeing on sort of institutional salary, like we're looking at sort of gender gap in sort of pay, but maybe we want to see how sort of family SES sort of impacts that, right? Now I could chop SES and just like split that, but we know that this is a continuous variable, right? That there's not just high, low, there's gradients in between that start to become important for different reasons, right? This is a hard thing to sort of go through and do in ANOVA unless we're going through and dichotomizing what we believe to be a continuous factor, okay? So again, can median split, right? But again, you read a paper that's going through, make sure that you read that paper, a lot of consequences, right? Because we're saying that everybody on the high SES is exactly the same thing at low SES, right? So you're saying that like the person who just tips across the line into high SES is functionally the same for your research question as Bill Gates and Jeff Bezos and Elon Musk and some like people who are sort of astronomical, if those people are captured, right? And the people who just sort of fall below that that SES line that you've created are the same as someone who is struggling on food assistance and sort of other sort of like intense poverty, right? That's probably not true, right? But in your model, you're treating them as though they're equal, okay? And so what this can do is it can reduce power, create biased effects. It starts to become problematic, and we've known this for a long time. But in your regression model, what we can do is we can go through and we can look at interactions in any combination of categorical and continuous variables, so long as we code them correctly. And what we can do is we can go through and we can retain all possible information that we have in our data set. This is very, very, very good. There's no reason to go through and dichotomize something when we can just go through and like keep this as a continuous variable and model that in and look at sort of the full range of scores and the effect on an outcome without having to pretend that people are the same when they're very clearly not. So what might happen before is like, oh, I'm going to go through and I'm going to look at it this in sort of this group of people, and then I'm going to look at it this group of people separately. I'm just going to run this regression in these two subsamples, and then I'm going to see if the coefficients are different. Well, you can do that, but you just cut your sample in half, and so now your power went way down. And so like you're actually not better off for that, right? You can do it and conceptually I see what you're talking about. It's just, it's a problematic strategy. So through this, we're going to use the same sort of example data here, just so you don't have to keep sort of wrapping your head around sort of different variables. And we use this in our regression example, okay? Our questions here, and we've got a couple of them. want to say, do opiate medications influence the impact of pain on rural functioning in survivors of accidents? And then does pain severity change the relationship between PTSD and functioning following motor vehicle trauma? Okay. So before, if you remember back to our original regression model, William, did opiates have an effect in those initial models? Do you remember? No, it didn't, right? They did if you just look at opiate use and functioning, but then as soon as we threw pain in there, that all went away, right? So what you could do with a straight regression model is say opiate use isn't important, right? It's not a useful thing because it just goes away. But what I might be doing is missing the fact that, yeah, there's not a unique effect of opiate use, but opiate use might start to change the nature of how pain relates to functioning. And if we think about what pain medication is supposed to do, like hopefully I would see that, right? Because if I'm taking pain medications, though pain medications are working properly, I should see maybe a reduction in the relation between the link between pain severity and functioning. That should be helping and maybe sort of start to decouple that a little bit, right? So again, thinking about with a standard regression, sometimes our standard regression doesn't do a good job of actually capturing what we think maybe is going on with this, particularly if we got variables that are starting to bounce off of one another. Okay. So again, you're measuring pain, opiate use, PTSD, and then our rural functioning variable down here. All right. We'll go through cover centering. Okay. Who here is familiar with centering? Ever heard about centering? Got in the middle of centering? A little bit, yeah. Tell me what you know about centering.
Subtract the mean from each individual X
Yep.
value so that the middle of the distribution becomes 0.
Yeah. In regression, remember that I told you 0 is a magical number. Okay. You need to know anytime you're looking at a regression model, particularly within the context of moderation, what does 0 represent? This is a critical thing. Okay. Now 0, sort of normal on your raw scale, may mean the absence of whatever you're doing. It's the low score, or it's also often not a value that's actually there useful for anything, right? Like I've got a measure that's scores range from 20 to 100. 0 is not a real value on my scale. So if I'm saying holding sort of this variable constant at 0 doesn't mean anything because 0 is not a real value on that scale. So conceptually it starts to create some problems with some things, right? So what we can do is we can go through, before we run our analysis, we can go through and center our variables, okay? And just as William said, what we're doing is we're just rescaling this to set the mean equal to 0. So now if I'm saying, here's the effect of X on Y holding W constant at 0, what am I saying? What does 0 represent, Jack?
So
Yeah, the average, right? So now I'm saying this is the relation between X and Y at average levels of W. That's kind of a useful concept as opposed to 0 as in like it's not there, right? And so what we did is we just went through and started to increase the interpretability of my model, okay? And so like William said, what we do is we just take every score in my sample and I subtract them from the mean, and what ends up happening is now the mean value is 0. Anything that's positive is by definition people who are above the mean. Anything that's negative, people below the mean. Okay. Different than standardization in that my standard deviation is the same. If my mean of my unstandard variable was 45 with standard deviation of 10, as soon as I center, my mean is now 0, but my standard deviation is still 10. It doesn't change. Okay. Jack, does it change the shape of my distribution? No, it doesn't change the shape of the distribution. It just shifts that scale around. Okay. So again, here we're seeing my uncentered distribution here. I've got a mean 5.6, standard deviation of 2.3, right? And here is 0 on this. 0 means sort of the very bottom. Okay. So I go through and I center this. Now all of a sudden my mean is 0 because I've taken every score in my set, subtracted the mean. And so my mean is now 0, but my standard deviation is 2.3. 0 now corresponds to my mean of my distribution. And now negative 5.6 is this person who was 0, their score is now negative 5.6 because they took 0, I subtracted subtracted 5.6. So now that's where they're at. Okay, so we're just shifting the scalar out. We're not changing the variability. It's not a transform like we would like a nonlinear transform. It's not like a log transform. We're just shifting the scale around. And we're doing this so that 0 means something specific, and I know what 0 means, and it's useful for me to know what 0 means with things. So again, benefits of centering, more interpretable models, and it helps with the calculation of interaction effects here. And historically, so this was done to address collinearity associated with your interactions, okay? If you go through and I have my variable x and my variable x1 and x2, and then I take sort of my interaction and I create that as the product of x1 and x2, the product of x1 and x2 will be very, very, very highly correlated with x1 and x2, right? And what I do is I introduce multicollinearity in my model. We talked about how that was problematic, okay? And so historically, one of the main benefits that have been touted for centering is it reduces that collinearity in my variables. Now in OLS regression, from a practical standpoint, this has 0 effect on anything that you're actually estimating. Well, like the p-values, your standard errors, and things along those lines. This type of collinearity doesn't actually change anything, right? And so what you'll see is in the literature, particularly among Hayes and sort of some of his stuff, is kind of a pushback against centering. And what's happened, and this is unfortunate, is because since the time I've been doing this, sort of a heavy emphasis on centering, so why it's good. And sort of one of the things back, oh, well, it reduces collinearity in your model, therefore you have to do it. In OLS regression, it actually doesn't change that at all. It doesn't change your estimates, your p-values, or anything along those lines, right? It changes your intercept, but that's it, right? But I imagine that Hayes got tired of having people scream at him they had to center his variables when it actually doesn't have any impact on things. That's because people were shouting at him, like, don't understand that it actually doesn't do anything. And so what you'll see in a lot of the process literature is you can center, but it's not required. But there are reasons sort of to go through and center things. And also, if you're going to go through and start loading things into, like, it doesn't make a difference at OLS, but the type of collinearity that you will get in your variables, if you go through and like run an SEM, if you run that in a maximum likelihood environment, that'll blow everything up. It'll ruin it, and you'll just get non-positive definite errors and things along those lines, right? So just sort of be aware sort of what this is doing and why, and so we'll go through and take a look at some stuff. So OLS regression, do you have to center? No, but in a lot of ways it makes your life easier, so it's worth going through and doing it anyway, okay? Other thing too, when we're centering our variables in these models, for your standard models, we're only measuring, we're only standardizing, or we're only centering your predictors, okay? Write that down. Not your Y variables. Don't need to center Y. Don't center Y. Just center your predictors. So effects of centering. One is just rescaling. You're just by a constant, right? No impact on the variability or shape of your distribution. Not going to change your correlation, your regression coefficients. That's going to all stay the same. It's going to change your coefficients in models with your interaction effects, except for coefficients at your highest order term. Okay, this is important to know because it's going to. These are the things that are going to start to tell you whether or not you run your model correctly. With moderation, there are several things that are going to be your fail-safe checks. You have to have those and be able to look at your output and say, is this model behaving the way I would expect? Because if not, you're going to make mistakes and you're not going to know you make mistakes, and then things are going to be off base. Okay. Really, this is the reason I would say it's important to go through and know the nuts and bolts of this. Like, I don't run these models without making mistakes. I still do, because there's just about 1,000 different ways you can make mistakes in them, right? But where you go through and catch it, if you're like, okay, if things are working right, that coefficient shouldn't change, that one shouldn't change, that one shouldn't change, that one should. And if I run my model and something's not sort of squaring with what should happen, then I know I've made a mistake somewhere. Okay. So this is diagnostic to keep track of this. And so if I run an uncentered model and I run a centered model, what I will see is with an interaction, what I will see is changes in my coefficients, except for whatever my highest order interaction term is. So if I've got just a two-way interaction, that two-way interaction isn't going to change whether or not I'm running centered variables or not. If I have a three-way interaction, then my three-way is going to stay the same. My two-way interactions are going to shift around, and my lower order effects are going to shift around. Whatever your highest order interaction is going to be identical whether or not you have a centered model or an uncentered model. But it's just important to know kind of how that's working out so you can go through and problem solve your models. Okay. Simple slopes, not going to be impacted by centering. Shape of your plot, not going to change as a result of centering. Okay. So centering is a valuable thing to do. We're going to do it. I would encourage you to sort of think about centering in your models that you're going to run. Just know what it does, what it doesn't, and sort of use that to create information about whether or not you've run your model correctly. Because again, you'll make mistakes, and that's fine. That's just part of doing applied research, is just knowing where those are coming from and being able to say, oh, okay, I went through and did this or that, right? Okay, so want to start with our straight multiple regression model for our accident example, right? Here we've got the prediction of functioning based on pain, opiate use, and PTSD. In our centered solution, okay, pain and PTSD are going to be centered at their respective means, okay? I'm going to encourage you to continue to center your dichotomous variables, even though like centering doesn't make a lot of sense. Zero doesn't make a ton of sense on a sort of 0, 1 variable, but what it does is it kind of just averages things out, right? If I don't center, then I'm looking at the unique effect of PTSD and pain for individuals who aren't using opiates, because 0 reflects no opiate use. If I go through and I center opiate use, what that does is it says this is the unique effect of PTSD on outcome at average levels of pain, controlling for opiate use, just kind of splitting the difference here. Okay. Now, in these data that we're going to go through and look at, when I go through and I center opiate use, it's going to result in sort of negative 0.5 being no use, 0.5 being use. Everybody look at me in the eyes. This is only the situation in these data because I have almost exactly the same number of opiate users and not. Okay. If you center these properly, it's almost certainly not going to be negative 0.5 and 0.5 because you're going to have maybe a few more people in one group than the other. And if you take the average of 0 and 1, and it ends up being 0.4. And so you go through and subtract everybody's value from 0.4, right? You're going to have sort of people who are in the no use group be negative 0.4, people in the use group 0.6, right? So just know that this is only happening because we have a balanced design. Don't assume that sort of no use and use in a centered dichotomous variable is going to be negative 0.5 and 0.5. That's just only happening in this sample. So if I go through and I center these and sort of regress this on, what I've got, here's my regression equation. I've got my intercept, negative 10.7 on centered pain, negative 0.69 on opiate use, negative 0.3 on 0.23 on PTSD. Okay. Jack, tell me can you give me an interpretation of this intercept coefficient here?
When pain, opioid use, and PTSD are all held constant at 0, the y is equal to 48.2.
Yeah, the expected value of y is equal to 0.2, right? Not to say like for every person that's where it is, but sort of based on my model, my expected value is going to be there. Okay, perfect. And then what I want you to be doing is we work into moderation. Start thinking about what does 0 mean. Okay. So what we're saying here is that if I'm looking at my coefficient for pain, right? What I'm saying is, or I guess sort of go back to your intercept, you're saying for people with average levels of pain and average levels of PTSD, when we control for opiate use, my expected value of functioning is 48.2. Okay. It's basically just plugging in sort of like, what does this mean, right? If I were to go through and run my uncentered model, whatever that coefficient would be, would say For people who are not using opiates, who have scores of 0 for PTSD and 0 for pain, this is the expected level of functioning. And William, do you think that intercept would be a different number? 100%, right? Because we're talking about a completely different person. We're talking about someone who's not using opiates, who has no pain and no PTSD. I would expect functioning to be very different for that person based on my model than someone at average levels of pain, average levels of PTSD, controlling for opiate use, okay? Really, really, really want you for these models to start thinking about these equations in that way, right? So here, if I'm looking at interpreting my coefficient for pain, what I'm saying is I would expect for every unit increase in pain, a 10.71 unit reduction in my functioning, holding PTSD constant at the mean and controlling for opiate use, right? That's a very different thing than saying 4 people with 0 scores on PTSD and no opiate use, right? 0 starts to become really, really important. You always want to know what 0 means for all of your variables and make sure that you've got a handle of that, because that's going to start to be critical for interpreting what's actually going on in your model. Okay. So again, finish up here quick with our uncentered solution, our centered solution. Here is our uncentered solution. Here's our centered solution. R is the same. R squared is the same. Everything's the same up here. My t value for each one of my predictors is the same. My unstandardized coefficient is the same. The only thing that's different here is going to be my intercept. My constant is different because I'm sort of looking at prediction of functioning in different people, right? Here, I'm looking at the prediction of functioning in individuals with scores of 0 on pain severity, scores of 0 on PTSD with no opiate use. Then yes, I'm going to expect that score to be higher than in a situation where the predicted expected value of Y for people with average levels of pain and average levels of PTSD controlling for opiate use. Here's what we got. Okay. So again, centering doesn't do anything in this straight up horse race multiple regression outside of changing your constant coefficient. Most of the time we don't care about the constant coefficient, so it really doesn't do much. I mean, it helps with interpretation, but it really doesn't have any practical effect on this. Yeah.
Like if we had the example from before where we had a dichotomous variable where it wasn't like balanced, so like it was like the negative 0.44 and 0.56, would the language still be like controlling for?
Would still be controlling for it, right? Because we're just kind of splitting the difference. Because a 0 value doesn't make any sense because that's not a real value, doesn't represent anything. It's just kind of averaging out, balancing out that. Okay, cool. I am feeling good about where we're at. Any questions with material that we've covered up to this point?